Hi everybody, this is to kind of do a overall review of what we've done with factoring so far. And we really have done all four of the major types of factoring that you'll be doing in this section. I would like you to have 09DF page 35 out. It looks like this. And essentially, the way this is done is 1 through 8, they are the same problems as 1 through 8 here. These are just about identifying what type of uh, factoring situation that you have, okay? So each of these we're going to label either as an easy one, a difference of squares, a perfect square trinomial, or what we call a hard one. He calls it the magic number. I call it magic box. But in this case, let's identify each one. Well, the first one, I have A is not equal to something other than 1. I should say that A is equal to 1. It's an easy one, right? It doesn't have perfect squares on either side, so we would label that as an E. This is going to be an easy one. In fact, that's the kind that we're going to use the little X tool and factor with the two numbers that we get from the little X tool, okay? A difference of squares, that would be if the first term and the last term are squares and there's nothing in the middle but a negative sign. That's literally a difference of two squares. That's what we have on number 3, kind of going down the column rather than across. Okay, this one again, I'd be looking for squares, but 40 is not a square, so I'm going to call this an easy one, assuming it does, in fact, factor. Okay, this one I see that 16x squared is a square number and 49 is a square number, but I have to test this one before I declare that it is a perfect square trinomial. The way I have to test it is I say, what's the square root of the first term? Well, it's 4x. What's the square root of the second term? Well, it's either plus or minus 7, okay? And then if I multiply these two together, I get 28. If I double them, do I get the middle term? Yes, I do. 56 doubled, or 28 doubled is 56. And because there's a plus in front of the 56, this is going to be the plus 7 root of 59. And actually, I've already factored it, so I might as well transfer that answer down here. This is going to be 40x plus 7 squared, okay? So when you test perfect square trinomials, once you've determined that it in fact passes the test, you already have the factorization, all right? So that's a perfect square trinomial, all right? Right now we're just identifying, but I mean, we might as well put it down there. Okay, this one, I see another perfect square here, and I see another perfect square here, so I might as well test this one out. The square root of 81x squared is 9x. The square root of 16 is plus or minus 4, okay? So if I multiply 9 times 4, I get 36, and if I double it, do I get 72? In fact, I do. So this again passes the test, and the fact that there's a negative here means I'm going to take the negative square root. So again, I think I'm going to go ahead and write this one down since I actually have already factored it. This one is 9x minus 4 squared, okay? Perfect square. All right, this one, not a perfect square. 9 is, but not 5, and I can't factor 5 out, so this is what they call a hard one, or I'm going to use M for my magic box. Really not that hard if you use the box. Okay, this one looks a little strange, but this is a square number, and 9 is a square number, and they are separated by a negative sign, so this is a difference of two squares, so we're going to factor that way. And then finally, again, A is not equal to 1. There's a 3. I look to see if I can factor 3 out, and I can't factor a 3 out of the 25. So this is going to be one of my magic box ones. Okay? Well, I've already done my two perfect squares. So now I'm going to go ahead and start doing the actual factoring here. Okay? All right. Easy one. what do we do here? Pull out our little X tool, okay, and put A times C in the top, B in the bottom. Two numbers that add to positive 4 but multiply to negative 5. I get positive 5 times negative 1. There is my factorization. Right? Differences of squares, they're really just as easy as these. Just identify the roots. So the square root of x squared is x. The square root of 144 is 12. And this is where we're going to get the plus minus pattern. So we could say x plus 12 times x minus 12. Or we could do vice versa with the signs. Okay? This is another, quote, easy one. We're going to use our little x tool. A times C is going to be 40 on the top, since A is 1. And then 22 in the middle. And I think about two things that multiply to 40 but add to 22. Give you a chance to think about that for a second. I get 2 times 20. Therefore, this factors 2, x plus 2 times x plus 20. If I FOIL this out, I will get this trinomial. Okay. I'm going to skip the two hard ones. Mainly, it's a little bit of a space issue here. I'm just going to go down to the difference of squares first. The square root of x squared y squared is xy. And again, I'm going to have a plus minus pattern here. So I could say xy plus 3 is the square root of 9 times xy minus 3. That's been factored. And now I just have these two. Again, I could try doing some guessing and checking for this one. 5x squared can only be made by a 5x times an x. 9, though, can be done either 3 times 3 or 9 times 1. And I do have a negative here, so I'm going to use the box, okay? So I'm going to be giving myself a little bit using the room I've got here. In fact, I was going to say I could do it on my board, but let's see here. 9 times 5 is 45, and I get negative 46. Oh, that's not too bad. Negative 1 times negative 45, right? So that's my inner and my outer. So if I plop those guys in my box, I have 5x squared and 9, negative x, negative 45x, and I am factoring out, okay? So here I've got a 5x in this column here, common, and I'm going to go this way, 5x times x. To get this negative x, I have to notice I really have to have a negative 1 here. X times negative 1 will give me that negative x, and then negative 1 times negative 9 will give me that positive 9. Okay, so here is my factorization. 5x minus 1 times x minus 9. At this point, I'd like you to pause the video and see if you can work number 8 on your own. You've had some practice with this so far, and you've seen me review it. See if you can do number 8 on your own. Okay, hopefully you've had a chance to do that. I am going to go through the process here where I've got 3 times negative 18 is negative 54, positive 25, and doing a little bit, if 54 has a lot of factors, doing a little bit of knowing that one of those factors has to be bigger than 25 because that's the only way I'm going to get negative 54. I have to have a positive and a negative. So as it turns out, 27 times negative 2 will add to 25 and multiply to negative 54. So now I'm going to put these guys in my box. Drop my first times first, my last times last. Now I can put my outer and my inner in. Okay, and factor out. All right, in any order I want, but I see a negative and a negative, so I'm going to use this one first because this will take care of my negative. There is a -2 common to these two in this row. Then there is a positive 3x common in this row. That means this has to be where the x is in order to get 3x squared. And now I can go up this way. I have to have a 9. And I do need positive 9 times -2 in order to get -18. So here is my factorization. Right there, right? Okay. So that's kind of a rundown of all 4 different ways that we've done factoring and a review of that. You've got some homework that you'll follow up with this.